Hola, Mr. Lee here. We're gonna do this one Khan Academy exercise um, just to help you out with your practice for today. So, interpreting graphs of proportional relationships. Okay, so let's read this together. Local gas station charges a certain rate, dollars per liter, for gas as shown in the graph below. What is the price of gas at the gas station in dollars per liter? Okay, so in this exercise, we're going to hopefully mix a bunch of your topics that you've been learning, unit rates and your graphing skills. So this one's all about unit rates, right? If you look at this um, label right here, dollars per liter, right? So how much does it cost per 1 liter? That's your unit rate definition. So really, we're looking for a unit rate. So let's look at the graph here, and we can use our graphing skills now to label some points to see if we can figure out what the unit rate is. This first point tells us everything already because we have, if I scroll down a little bit, we have on your x-axis your liters of gas and your y-axis total cost in dollars. Okay, so really important for each of these problems, if you can label your x and y, do it. And keep track of what they mean every single time. So dollars per liter again for the unit rate. This point that they give us will be looks like a 1, 1.5, right? Okay, so it's as simple as this. We want to figure out what the cost is per 1 liter. So in this case, we're going to put the y over the x, right? Because the y is the cost and the number of liters is the x. So this is just going to be 1.5 over 1 in this case, right? 1.5 dollars for every 1 liter. In this case, it's already the unit rate, right? Because our denominator, our x value is 1, so we can just take 1.5 as the answer, okay? So you might think I'm over-explaining, which I kind of am, but I want to make sure I hit home that you're looking for that unit rate. Not all examples will necessarily look like this, okay? So 1.5, that's good. Let's see if we can do one more example. Okay, we got a hot air balloon is rising at a constant rate. The relationship between its height above the ground and the time since it left the ground is shown in the following graph. Okay, so hot air balloon takes off, time passes, it reaches a certain height. This is like your graphing stories. Okay, so let's see which ones are true. We're going to choose all that apply. The 0.00 shows that the hot air balloon is free to ride. Okay, well, let's label your x and y again and see what's going on here. So x is your minutes, and y is your height. So if I label this point here on option A, x comma y, that means if we're using our labels consistently, that means at 0 minutes, we should have a y value of 0, which means the height is 0, okay? So that has nothing to do with the cost, okay? This is saying that the hot air balloon is free to ride. Neither the x value or the y value in its label is talking about price or cost. So that is actually not true. We don't know that for sure. Okay, it's inconclusive. So we're going to skip that one. That is not an option. We can only relate minutes and height. Minutes and height, which is not represented by this sentence. Okay, so let's scroll down. Let's keep going here. A didn't work. Let's see if B works. The 0.240, again, I'm going to label it. So x comma y. The 0.240 shows that the hot air balloon is at a height of 2 meters after 40 seconds, okay? So let's make sure we read our labels. X is 2, which means we're at 2 minutes, right? 2 minutes. And then your y value is 40, which means we're at a height of 40 meters. So let's see if that matches what they say. 0.240 shows that the hot air balloon is at a height of 2 meters after 40 seconds. So this is wrong. This is actually the flip, right? We want 2 minutes for 40 meters, not 40 seconds for 2 meters, okay? So look at the units very closely. They don't match. So actually in this case, neither of them are true. We're going to press none of the above. And just going to show you one example today. But as you're doing these, don't forget, apply your unit rates. You'll see different variations of these problems. Unit rate and your graphing skills, okay?